Hello and welcome to another edition of the Low Code Cafe. This is episode 119 for November 30, 2022. I'm Dale Warner, Head of Support for Plantinap. Today we're going to be talking about going in circles, recursive workflows, and it's a topic that I'll be presenting later on in this webinar. The Low Code Cafe is an event we do every Wednesday this hour, and it's an update, it's an opportunity for us to update you on what's going on with Plantinap and talk about the issues going on with support, but we dedicate the largest chunk of the time to a technical topic, as we will today with recursive workflows. If you have something that would be of interest to the community, we would invite you to come and join us, be our guest speaker. Just reach out to us and we'll be happy to find a slot and put you on. All of our past episodes are recorded on youtube.com/plantinap. So you are invited to go subscribe, set the alarm bell so that you know exactly when instantly when we release new content. Today's agenda, I'll talk some about from the trenches, the things that are going on with support, and then we'll get right on into our hands-on low-code development. You're welcome to interact with us in a variety of ways. You can use the chat window, the Q&A. You can raise your hand and ask a question directly. And after the event, you're welcome to and invited to fill in the feedback form. So let's dive in. On our current version, 1.23, we previously released 5 hotfixes. There are 4 this week, and they are all enhancements. When you add the first, new tabs modules have Bootstrap 5 as default. So this would mean when you're dropping a tab module onto a page, it starts out, it assumes that it's going to be Bootstrap 5 as we consider Bootstrap 3 to be obsolete. We have another release, another thing with our page builder, the navigation bar enhancement. The branding colors are getting loaded earlier in the process. This was a cosmetic thing where pages were loading and they were loading with our default colors and then switching to the colors that you selected. And that's a little bit of a jarring experience. So we're loading them earlier in the process. We have also noticed an issue with the help text for create CSV from list. And so we've updated the inline help text to better describe what's going on there. And then for one of our clients, Ben, this one is especially for you, that the query timeout has been added. So you can load an entity from SQL. Actually, that shows how old that request is. It's now create a list from SQL, but the query timeout has been added so that if you're expecting the query to take a long time, you can enter a parameter. I don't remember if it's seconds or milliseconds, but you can specify how long that you want to wait for an answer. So if you have long-running queries, it'll still not time out. So those are released in 123. Beyond that, a programming note, every Friday we do low-code campfire. It's the same hour, and it's an opportunity. Instead of a webinar format, it's a meeting format. You can meet directly with us and talk to us and each other about the things that are going on. We often see problems and issues that you're facing solved while we're on the call this hour in campfire, and it really is the best part of my week. So I do invite you to attend. Another programming note, for the last few years, we've done an end of year episode. We're scheduling that for December 21st. So Low Code Cafe end of year episode will include things like the year in review. You'll see a sneak peek of our knowledge base, and then a discussion with Bogdan about our product roadmap and more. There's always more. So put that on your calendar. We have links for this episode, and let me put them out on the webinar chat. These are how you can register for the Low Code Campfire, get to our recordings, get to the community portal, which is a great resource to get questions answered, and our feedback form. We're going to be talking today about recursion, and I found a nice definition of that in Wikipedia, so that's there as well. Great. So with that, we'll dive on into hands-on low coding. And, I cleverly named it Going in Circles, Recursive Workflows. So today we'll do the general outline of where we're going. We'll do we'll take a look at an example solution that used recursion. We'll talk about how recursion and workflows go together. We'll talk about the definition of the problem that I was facing when I put this together. We'll take a look at the data that we're going to use. And then I did something a little bit different. I did a design statement. I don't know if that's a technical term, but it's my terminology for stating the problem in English. So I did a design statement. We'll take a look at that because it helped me to build the workflows. So then we'll get into building the workflows. I'll add a few closing thoughts and maybe time for your questions. So first, let's think about I'll show you exactly where we're going with this. We'll take a look at an example solution. This solution builds on at least three episodes that we've done in the past. One by where we had a guest speaker, Jerry Maddox, that showed us all about how to do dynamic Google Maps. So that was episode 81. We imported the national address database, and that's core to this solution. And we did that in episode 114. And then a couple episodes back, we did distance between points, and that again is core to what we're going to do today. So these things build on each other. And if you're new to the group or new to these recordings, I just wanted to let you know there's other recordings that might be helpful. The premise of what we're doing, the application that I was trying to build, is that we're sending teams of people to visit all of a selected number of addresses. This is community-based. It's a church functionality that I'm building, and so we're sending teams of people to all the addresses in a geographic area. And we want to, as we send teams out, we want to group them together, group these addresses closely together so one team isn't spread out all over town with different addresses. We wanted to focus them in on a particular area. They can hit it efficiently and then move on. So that's the premise. Let's see what it looks like. I have the application going here, and let's see, I'll do some resetting here. I have address targeting is one of the things that is built in. And so I'm going to just clear this out and start over. I'm going to search near my house, which was at this address, and it gives us the latitude, longitude. I want to go to houses that are within half a mile of my house. We'll count those up. And with that, there's 270 of them. So there's some SQL behind the scenes. And again, using that distance formula that we talked about a couple of weeks ago to get me the number that are within that distance. And so I am going to select those for this mapping functionality. And so after having counted them up, they'll be added here to our number selected, and we're good to go. So that's the address selection piece of this. What we get out of this is immediately is an overview map that relies again on that solution provided by Jerry. And so these are all of the addresses that are nearby. And so we have, this is in a way, I wasn't able to illustrate it, I think, when I did it a couple episodes back, but the quality of in the US, the National Address Database, having latitudes, longitudes for all the houses. If we zoom in here, we can see that everywhere Google thinks there's a house, we've got an address, so a map point. I've chosen this yellowish icon with the pause icon on it to say these are available, but we haven't assigned them to anybody yet, so they start out as yellow. That's my color coding. And clicking in on them tells us the exact address. So the functionality that we're going to talk about today and build, or at least review how it was built, is the functionality where we assign the teams to the addresses. We have 5 teams, and let's say we're going to, I'm just going to arbitrarily say we're going to assign 30. So 5 times 30, 5 teams, 30 addresses each. They are going to, that'll use up 150 addresses. We've got 270 in this available to visit. So when we assign them, and this is calling a couple of workflows that we're going to focus on extensively, but now we see that 150 have visits pending, and then there's still 120 available to visit. When we look at that in the overview map, we see the white ones now are the ones that have been assigned, the yellow ones remain available. Each of the teams are handled by name, and so we can apply a filter, and it's going to just show me the ones that were assigned to a single team. And this is kind of a spot check to see that all the addresses that were assigned to a team are nearby each other. So this particular one got all of this on that street, and all of this on that street, and a few on this other street. So all the addresses are relatively adjacent and would be easy to navigate. Probably not as good a job as somebody assigning them by hand, but a nice formula to get it done quickly. All right. So with that, we've pretty well defined kind of where we're going. That whole the logic that is behind assigned teams to addresses. And just to kind of show how simple something can be, if we look at the actual button to assign teams from addresses and roll on down to the on-click handler, it executes a single workflow. It's executing the door-to-door assigned teams workflow, passing in what event needs to be assigned and how many people. So it's just such a very simple call. So once you've got a well-designed workflow, you can call it and just in very cleanly execute and incorporate that functionality into a form or other anywhere you need to. That workflow can be called. Great. So that's the target. That's where we're going. Let's move on from the example to talk about workflows and recursion. So I got this definition from Wikipedia, that it's a procedure that goes, is a process. A procedure goes through when one of the steps involves invoking the procedure itself. So calling itself. And so that's what we're going to be taking advantage of. Plantain App does this, it handles this quite cleanly. And so each iteration, when you start with a workflow that you're familiar with, you have a unique context. The variables that are available in that workflow are empty. And so when you set them in that workflow and then call that same workflow again, directly as a subordinate, that's a new instance of the workflow, and that will also have empty variables. So you can pass a set of variables from the workflow to a subordinate call, and it can do the work. And if it needs to, it can call even to a lower level. And each one has its own unique space or instance, and so that it supports this recursive concept very well. So we're relying on that in the solution. I've already kind of talked a little bit about the definition of the problem, but we'll get into that a little bit more. Teams are volunteers, so we don't know how many teams are going to show up at any given time, and so it's known only at the last minute. So we're setting ourselves up, we're selecting addresses in advance, and then assigning the teams at the very last minute as they head out to go visit. We want the addresses to be adjacent or as close as possible, and so that's part of the definition. And then the way we're going to accomplish that is that we're going to assign addresses along the same street until you reach the maximum number that they're supposed to get, or if you need to, if the addresses are exhausted, we'll pick another nearby street and start assigning from there until we reach the maximum or run out of houses. And so that's the recursive nature. We're just we keep calling the same routine over and over again until we've fulfilled the number that we need. Part of this was made possible by the fact that the national address database is so clean. And let me see if I can find that. That's our map. Here's the national address database. So within, or at least something derived from the national address database, I have this column called CAD. It's the concatenated address components, but and so we'll be referring to that as the CAD. But you can see it has very clean values. There, when I originally approached this problem and getting the data from another place, the data was not clean. So drive, for example, sometimes it was drive and sometimes it was DR. Well, we can use this, and I'm going to search for my street. We can all of this. The St. Orland ways are exactly the same. So when we want to start from and find houses along St. Orland Way, we can rely on this CAD to be consistent. And so if we're at one address and we want to find an adjacent address, we can simply use this CAD to search for it. So that's a key part of the data that I wanted to point out and what makes this part of the solution possible. So I mentioned earlier I did a design statement, and so I'm calling a design statement. It stated my solution to the problem in English. I dealt with what the inputs and the processing and the outputs would be. And as I considered it, I thought, okay, this could be elegant. We'll do it recursive. And then we had to have a definition of when to stop. So when we run out of addresses or we've hit the maximum for a team, we can stop. And so that's kind of the definition. I got into this design statement. It's kind of forced on me. Oftentimes I just open up a workflow and start working because I can kind of do it in my head. And then I was on a plane with only my tablet and no internet. So I thought I will do this design statement, and I'm going to show it to you. But it actually made the development of the workflow, when I actually sat down to do it, I felt like I had planned it really quite well. It was block by block in the workflow matched up with my design statement. So sometimes, and especially with more involved problems, it's better to do some analysis and then before you actually start work, which is a little bit foreign to my DNA. So let's look at the design statement I came up with. I kind of defined the problem that where I'm going to have some unique IDs, some latitudes, longitudes, and this concatenated address that I could rely on. So that gave me a starting point. And I gave my workflow a name. This is going to be the assigned teams one, and the overview of what it was going to do. We're going to assign based on the assumptions we've already talked about. And I came up with it really needed two inputs. What event am I assigning for, and how many maximum am I going to assign? Because it's unreasonable to, just because I picked out 1,000 addresses, a team is not going to visit 1,000 addresses. So we wanted to allow being able to apply a maximum. The process that this top level needed to do is to figure out how many teams. We're going to read the teams that are available to get the count of them, how many map points or addresses so that we have a number of those, and then do a little division to come up with how many map points we're going to assign per team. So long as that's lower than the maximum, we're going to divide the list up evenly. And then we need to loop through those team records and call the subordinate one. So you're going to find when we get into this workflow is really quite simple. Again, it's kind of an elegant, I think, solution. When we loop through, we need to call and assign the map points to all the addresses to the teams. But then wherever they ended, we want to save that so that that becomes the place to assign for the starting spot for the next team. So you'll see us do some logic in there. And then when we're all done, we want to make sure that everything got assigned. The second workflow design was, this is the one that's actually going to do the work, and this is the one that is recursive. The other one is just looping. It's calling this subordinate once each for every team. This one's actually going to be recursive. So the inputs to this are the event that needs to be assigned, the team that's getting assigned, how many we're assigning, where we're going to start, and then this runaway level. We'll talk about this more, I think, but as soon as you start doing a recursive workflow, one that can call itself, there's the possibility you immediately introduce the idea of an infinite loop. So if you do it wrong, it keeps calling itself over and over again until it runs out of memory and it'll crash your application. It takes a while, and I mean, it'll recover okay, but it'll throw an error and waste your time. So and mess up anything else that's going on that server while it's doing, because it's going to run very quickly, take up all your CPU. So I have a runaway level that I'm using to make sure that we don't have an infinite loop. At some point it'll just quit and not continue. And then the output of this thing is, where did we end? So we're reporting to our caller where we ended so that they can begin at that spot at the next call. The process I came up with is that if we don't have a starting point, we're going to pick one just kind of at random, or in this case, we'll just start from a lowest latitude, longitude. So we've got a spot to start. And then whether we picked one at random or we got one from our call, from our input, we'll read that, and then we'll find the things that are nearby. So essentially reading all on the same street that are close. And if there aren't any, then we need to search for a new unassigned point and call our own routine again. So if we happen to have run out on this street, we're going to call the next street over and do it again. But if there are some, then we're going to assign them until we've reached the number we're targeting to assign, or if we run out, and then we'll do a recursive call. So this ends up keeping the amount of logic that are in our workflows very low. You just have to make sure you're able to call the same routine over and over again and not crash your system. So that was my design statement, and it accomplished it. It had all these factors. So let's take a look at the actual workflows that I ended up with. I'm not actually going to build it today. It took me about 2.5 hours to fully build these, and I'm just going to go through them as they are, because it's really less about solving this particular problem and more about how you can call things recursively. But we'll talk about the problem and see the recursiveness. So the first one, that top level one, is door-to-door assigned teams. And so it's, let me zoom in here a little bit, if I can find Zoom. And so it follows along that design statement really quite closely. The first thing that we do is some SQL to find all the different teams that we're going to need to assign to, and we bound that to the event that's come in from our input, and it produces a team list. I'm going to try to remember to scroll through all those, so even though we're not building them, anybody who's following along would be able to see all of the way it was built. So that's getting the teams as a list, and also we'll then be able to use that number, how many teams. So we're getting both the actual teams and the number of teams. In terms of the map items, the addresses, we're just doing, again, a SQL query. We're selecting the count for all of them that have the event ID. So this is going to give us a total number of addresses, and it's going to output that as total map items. So pretty straightforward, but it's going to, it just gives us something that we can do some math on. We're setting we're using a create update token to set some variables. So the map items per team, I really wanted this to be, it was based on dividing the number of items by teams, and I wanted it to round up. So I made a token that would accept those two values and return back a integer number, so it would be very easy to work with. So I did that through a database query, but this gives us back the number of addresses or map items per team. And I also wanted to, we said we're going to start at random. So we're starting with the starting map unique ID is blank. And so that gets us that far. We do a little comparison, the map items per team. If that happens to be greater than the number that we said with the maximum to assign, which came in through our inputs, then we just overwrite the map items per team to the max number. So if the number comes out lower, we use the result of the calculation. If it comes out higher, we use max to assign. And so now a very simple execute actions for each list entry. We just go through the team list, and every time we have a team, we execute the lower level item, which is we pass it. So this is the one that does the assignment to the team. We pass the event, the team that needs to be assigned, how many we want them to have, which was the result of our computation, and where it should start. And again, we're starting at blank, right? It's going to choose for us. We're also passing in a runaway level of 1. This is the top level. The count starts at 1, and you'll see us count higher as we go along. The output from this is, if you remember, we said that the output from that lower level routine is where did we end? And so the ending item becomes our new starting item for the next team. And so this just, as we iterate through and do the next team and the next team and the next team, it just picks up where it left off in terms of physical addresses. And that's it. So long as the subordinate routine does its work, each team is going to get their assigned addresses, and we're done. So let's take a look at that second level. And this is where we actually get into the recursion. If we take a step back here, you can see this is not a terribly long or complex workflow. I just kind of show you that as an overview. We'll talk through it, but the recursion happens down in here. So let's get set up. From an input standpoint, we have those ones that we just talked about. So the event, the team, how many they're going to get, where they're going to start, and this runaway level that, for at least the first call, starts out with number 1. And I guess we'll talk about the output. The output is just where did we end? So the unique ID of the item we ended on. So pretty straightforward. when I was, the first thing that I did is add a log event, logging the parameters that come in so that I could watch the recursion, see it happening. And specifically, when I started out, I started with a very low runaway level to make sure that it wasn't going to go crazy. And as I got into some real circumstances, it turns out that I needed it to be able to handle maybe 100 iterations of calling itself. And so logging this let me see, oh yeah, it's working and it's doing the right thing, but I needed to give a little bit of a looser definition of the runaway. So this is just giving me a clue about how many times it's running and what the parameters were. The very first thing that I did, we have in our flow section, the stop execution. So we can cause this workflow to stop immediately. And I mistyped here. This is my original. I was going to do 9, but when the runaway level gets greater than or equal to 100, this will just stop. And so that'll cause it just to immediately return and none of this logic to end. So it will quit calling itself. And so that's how I'm preventing runaway. From a variable standpoint, I'm taking the various inputs that came in and assigning them to some local variables, so, or local context items. So the starting map unique ID, the starting address is being stored as the map item unique ID. The number to assign is our remaining number to assign, and this is the one that's going to be reduced or decremented as I loop through and get each one. And then I'm initializing my output variable so that it's blank when I'm ready to overwrite it. So that's the setup that we do. From a logic standpoint, we said if the starting point was empty, we're going to pick one. So here's a selection that just goes, looks at my event data and picks one kind of at random based on the top record based on latitude and longitude. So that'll just give us one, and we're putting that into that map item unique ID. So if we had a map item unique ID, it would not do this. So it only does it if it's blank. So when one gets passed in, it knows where to start. When one doesn't get passed in, we pick one at random. Once we have one, we need to get some information from it. We needed that street name, the concatenated address, and the latitude longitude. So we're returning all those as the starting map item that we token that we can use those variables. So the next thing we needed to do is to get all of the ones that are on that street. And so this is where we're using a couple episodes ago when we did miles between points. So using that starting map point that we were just talking about, using the latitude and longitude that comes from that, we are selecting from our map items, and this is going to return the distance in miles from that starting point to the next point, and we're sorting it in order by that same thing. So it's going to sort, and it's going to return based on the street address and of course our event, something that is currently unassigned. So it's not assigned to a team and on the same street. It's going to return the closest one first. So this will give us a set that we can then work from, or a list that we can work from, and it's the map item list. So we're finally getting to recursion. We split one of two things is going to happen. Either there are some that we can assign, and that's the the list count is not equal to 0, or there aren't any that we can assign, the list count is 0. So let's start this path that there are some to assign. So we need to assign these to the team until the number to assign is 0. So the assignment, there's a couple of actions here, but not many. We are updating our map item to say that we're assigning them to a particular team. So we're using our map item list, and we're going through the map item list, and so long as there's at least one more that needs to be assigned, we are assigning it to a particular team, setting a visit status saying that it's assigned. With that same condition, we're going to remember that our ending map ID is currently the one that we're looking at, so we'll know where to pass back. And finally, we need to decrement this number to assign. So long as there's a remaining number to assign, we want to do some math, take the remaining number to assign and subtract 1. So starts out at 60, goes down to 59, 58. And so we're going to have some number left. We'll either finish up, it'll get down to, if it gets down to 0, then this loop will no longer assign any more to them, or if it's not down to 0, then we're going to do some recursion. So long as there's more to assign, we're going to call this exact same routine that we're in with the same event, the same team, and the remaining number to assign. So it started out at 60, but now there's 43 or some lower number to assign. And so the second instance will only try to assign 43. We're going to tell it where to start, which is where we left off from this one. And we're incrementing our runaway level. By doing that, the next iteration shows up as runaway level 2, and on and on. So when we get to 100, we'll blow up. But so long as we stay under 100, and each of these routines end okay, then it'll keep going on and on. And then whatever the ending map unique ID is, we're outputting that so that our caller knows where we left off. So when it's done, it's going to call the same routine and do that same logic and probably come down the same path over and over again until it has no more, until everything has been assigned, all the quantity for that team has been assigned, and then it'll end, and it'll just bubble up. If it's 7 levels down, it'll go to 6 and then 5 and then 4 and 3, and it'll end up going back and telling the calling routine where it ended. So that's one recursion path. The other recursion path is it didn't have, we were looking for something nearby, and it didn't have any. And in that case, we need to search for a new unassigned point and start there. So this same distance query we were working with before, it's going to go do that. So it's for the same event, looking for an unassigned thing that's nearby. It doesn't care. It's not trying to stay on the same street anymore. It's just going based on the last item that was assigned, last address that was assigned, and finding a nearby unassigned one. So that's how it keeps them. Even though it finishes the street, it finds one that's nearby. And then the result of that is going to be the new map item. And so we call this same routine again with that new map item unique ID, but otherwise we keep the remaining number to assign, keep up with our runaway level to keep things from going sideways, and that's it. So there's one of 2 courses that it could have taken, and it just keeps going until it runs out. We can all take a drink now.
Dale,
Yes, sir.
does it, and probably this is handled because of how close the next address is, I guess, but I'm wondering, does it assign the addresses consecutively so that if somebody's working through a street, they're going to, if it gets to be above the team's allowed assignment level, it's going to have just the remaining houses on the street, so they don't get so it works through a street up to a certain point. Is that accounted
Yes,
for here?
it is, and it was kind of implicit in this one. So if, let's say that they arrive at a street and there's, it's a signing on a particular street, there's 10 houses left, but their remaining number to assign is 5. So it's going to, it's in this loop saying, this is an execute actions on this. So it's going through all 10 addresses, but these actions are conditional. It's only going to work if the remaining number to assign is 1. So at first it's 5 and it assigns it, then 4, 3, 2, 1, and then 0. When it's 0, this doesn't assign anything anymore. Right. This
Right.
partially update doesn't work. This create update doesn't change the ending map ID, and this no longer subtracts. So these 3 actions are conditional and they don't run at all once it hits 0. So while technically the loop of this execute actions continues to run through the other 5 houses, it doesn't do anything. So it accounts for assigning them all along that street until they've hit their limit. Does that answer your question?
I think so, and but it's doing that based on the location of the previous address, so that I guess I'm just looking for, if it does end before that street, all the addresses on that street are complete, the remaining addresses are all at one end of the street, let's say, based on their.
Yes, and that is built into this logic. The order of
right. Okay.
The order of this, wherever your starting point is, it's picking the closest one, which ends up. I mean, it's doing it by shortest distance, so it's going to assign along that street in a according to distance. So it won't pick one end and the other and leave a bunch of houses in the middle. In theory, I suppose if you had a very twisty street, you could get some weird, weird impacts. And I don't hold this out as a perfect algorithm, right? I think ways to do this that might also get you there, or would get you there. But yeah, that's the way that I'm avoiding that big gap in there. Yeah, good question. If anybody else has a question along the way, here we've got 15 minutes. I'm going to kind of wrap this up here in a minute.
So one more related question: Did you consider the possibility of using the street address as an ordering, or and remove that from the possibilities? Or I'm curious.
Yeah, so I did spend a little time on that, and especially trying to figure out, for example, odds and evens are typically one side of the street or the other. So did I need to consider odds and evens? And I just came down to that distance really got me the same thing that I. So rather than and then there's who knows what's there with street numbers, right? That I mean, it's text based. Some street, like some house numbers are going to be 923A, and so you have a text sort, and maybe it's not going to do what you expect. So I kind of rejected that and went with distance.
Cool.
And, yeah. So putting it all together, and actually I think there's another I mean, this, control room ends up putting it all together. Again, we have a one simple call to the team address. There's this is more of a national address database thing that I think would be useful to illustrate. So I'm going to look for a particular address here. The point is, there is the data that comes from them is amazingly good. I just need to have there's a this is an apartment community, so we got a multi-story apartment community, and I just needed the road. This is I'm going to do, what is this? Well, we'll do Gateway Boulevard. That'll be good enough. So in our control room, if I return back here, and we'll clear out these addresses that are in my neighborhood, go to one that's got some apartment. Let's see if this will get us there. And so we'll do a quarter mile around there. Ooh, a lot. I'm gonna even bring it down just to a little. Okay, so there's 200 there, and so we'll select this set of addresses instead. So this is, again, less about recursion and more about the quality of the data. If we look at our overview map now, in working in this apartment community, we can see building by building that it's basically, it's a 3-story building, right? So we've got apartments, and so this is building 4, floor 1, 4105, 4205, 4305. So it's not just houses, it does apartments really quite well as well. And this is part of what I need to take into consideration as we're doing routing. It's going to be, the number that you might assign in an apartment community versus a residential single family housing where you've got bigger distances between things. It could impact your algorithm a little bit as well. But just been really impressed with the quality of data that's coming from that. Okay, so that was how we built the workflows, and I don't know. Oftentimes we try to do these live and a little bit of copy and paste and whatever, and so hopefully today just talking about them was useful. And again, the idea was focusing on the recursion parts. And I guess I got a little geeked out on the distance. My particular problem that I'm applying it to, but recursion very possible. So we talked about how to avoid an infinite loop, which one way is to just have that runaway. But you definitely, anytime you're talking about recursion, you need to think about, well, what if things go wrong? And it's easier to think about that in advance instead of when you crashed your website. And again, it's not a huge crash. It'll just add a processing delay and make it difficult for other people to use the site while it's looping forever. It occurs to me that there's other solutions that were possible to this that didn't require recursion. For example, as I'm assigning to a team, I could just always find the next address, the next closest address that's unassigned, and try and stay on the same street, and it would be kind of more of a one-by-one thing. And it would be, I think it would also be easy to read and elegant, but I think from a processing efficiency, this goes out and gets all of the addresses on one street and loops through them very tightly. instead of doing it one at a time. And as we get into thousands of addresses, time starts to be a factor. So there are other solutions possible. So Jim mentions that in his recursion solution, the equivalent of 100 levels is called by an automation job. And when the recursion reaches the max, it triggers the automation job again. So, yep, doing things, and I've done similar things with automation too, absolutely. That and it's just amazing the things that you can do. For example, in a scenario where you need to read data from another system and there's many pages, I just built it that we started out by reading page 1, and if there's another page, it calls the same automation, but for page 2. And so thinking in those terms can definitely make for an elegant solutions. And that's really my next point here. They can be elegant or confusing or unreadable or well documented, and it's up to you, right? Just like anything else we do. I've looked at very unreadable low code because you didn't comment about what you were trying to get accomplished in that step. And then I've seen very elegant and low, very easy to read and understand low code. And so you want to think about what you're trying to put together. And by the way, I want to, there was a conversation last week or last time in the low code campfire about using GUIDs on query strings. And we talked quite a bit about one of our participants' solution to that. And I would like to see their elegant code for doing that, because it could be, so I'm throwing out a challenge, Ben. If you'll come with that to the next time you come to Campfire, I would love to see how you do it, not just that you do it, because you've done it so much that having an elegant solution would be worth a lot more than me trying 7 ways until I figured it out. And then, with this, knowing that Plant and App can do recursion, so now you want to watch for these opportunities, right? It's going to, in this case, we're doing the same action over and over again. It's the same number of inputs, and we can figure out a way to make sure that there's a defined conclusion. In this case, we ran out of addresses or ran out of the number of, we've satisfied the demand of how many we were trying to assign. But you look for those opportunities and take advantage of that feature. And good, that's all I got. I'm giving you 6 minutes back. Thank you for attending. I hope you found some value in it. And if nothing else, I'll just mention in the low code campfire, you could probably twist my arm and we could take a look at, there's some other really nice things that we're building into that application. And again, a big shout out to Jerry Maddox for providing that nice interactive mapping. It standing on the shoulders of giants to be able to do that kind of stuff. So anyway, happy low coding. We will see you next week.